Hello, and we're finally at part 6 of section 5, 6.4 and 6.5. And this is all about solving inequalities. To solve exponential and logarithmic inequalities, you have to do it the same way that you did polynomials and rational inequalities. And that's by getting 0 on one side and then doing a sign chart with the zeros and undefined parts. So let's solve these inequalities. So for part A, it already is have 0. So now I need to figure out where is this undefined. Well, if you remember, the domain of an exponential is negative infinity to infinity. So there's no undefined parts here. So then we just have to worry about where does this equal 0. Okay, so we can add 16 to both sides. Take log base 2 of both sides. The 2's cancel out on the left. And log base 2 of 16 is 2 to what power equals 16, which is 4. Now we have a quadratic equation, so we go ahead and subtract 4. X squared minus 3x minus 4 equals 0, which is x minus 4. X plus 1 equals 0, which is x equals 4, or x equals negative 1. So now for our sign chart, we put where it's undefined, so nowhere, and then you put your zeros, so negative 1 and 4. Can we equal the zeros? Well, because of the equal to part of the inequality, yes, we can. So I'm going to put a closed circle above both of those points. Okay, next, you pick some test points. So, and notice when I do my test points, I put an X instead of a tick mark. That's because when you're using the same color or pencil, it's hard to differentiate between the zeros in your test points. So I would recommend doing an X. So we can do negative 2, 0, and 5. Now, as a reminder, you just take these and plug it into the original inequality that has 0 on one side. So, for example, we do 2 to the negative 2 squared minus 3 times negative 2 minus 16. What does that equal? 2 to the 10th minus 16. And I know 2 to the 10th, I don't know exactly what it is, but it's over 100. So this is going to equal positive. I don't care what the number is, it just matters that it's positive. Okay, and then 2, 0 squared minus 3 times 0 minus 16. 2 to the 0 minus 16. Well, 2 to the 0 is 1, so this will be negative. And then finally with the 5. So we actually get the same answer as when we plug negative 2 in, and we've already said that's positive. Okay. So I'm going to erase this so I have room to, because remember, this isn't our answer. This just tells us where we can find our answer. So since our original inequality was looking for greater than or equal to 0, that means we're looking for the positive. So our answers is negative infinity to negative 1 with a bracket on the negative 1 because it was a closed dot, union 4 and another bracket to infinity. And there's our answer. Okay. So for this next one, you might be tempted to multiply by the denominator because that's what we do with equalities. But my question for you is e to the x minus 4 negative, or is it positive? And if you plug in some values, you'll find out it's sometimes positive, sometimes negative. Like if we plug 0 in for x, it's negative. But if we plug 4 in for x, it's positive. So because it switches between negative and positive, you don't know whether to flip the inequality or not to flip the inequality. So if you have a variable in the denominator, don't multiply by the denominator. So what we have to do instead is subtract 3 from both sides so that we get 0 on one side. Then yeah, this is good. Now we want to know when is it undefined first. Well, because of the fraction, it's undefined when e to the x minus 4 equals 0. I'll add 4 to both sides and take the natural log of both sides. So it's undefined at the ln of 4, which is approximately 1.39. Good. Next, we have to solve for when does this equal 0. So when does e to the x over e to the x minus 4 minus 3 equals 0. Now this is an equation, so now I can multiply everything by the denominator, which is e to the x minus 4. So when we multiply by the fraction, it cancels out. Multiply by the 3, we get negative 3 e to the x plus 12 equals 0. Combine like terms. Subtract the 12 over. Divide by negative 2. And then we get x equals ln of 6. So it's 0 at ln of 6, which is approximately 1.79. So now we have our sign chart, which I will put right here. Put where it's undefined, so ln of 4, which, because that's where it's undefined, that will always be an open circle. And then put where it's equal to 0, so that's ln of 6. Now this depends, did our inequality have an equal to part or not? It did. So that'll be a closed circle. Now we will pick our test points, which I think 0 is a good one. 1.5 is another good one. And then 2 is a good one. And when you plug those in, you get negative, positive, negative. So feel free to pause the video if you want to double check those real quick. And then since our inequality is less than or equal to, we're looking for the negative. So our answer is negative infinity to the ln of 4, parenthesis, because it was an open circle, union, bracket, ln of 6 to infinity. Now for c, we want to get 0 on one side, so I'm going to subtract 4t, subtract 4t. So then we get t e to the 2t minus 4t less than 0. So again, you find out where it's undefined. Well, the domain, again, for an exponential is negative infinity to infinity, so there's no undefined parts. And then you solve for when it's equal to 0. Well, this is equal to 0. We can factor it by factoring a t out. So we get t equals 0, or e to the 2t minus 4 equals 0. Add 4. Take the ln of both sides. And then divide by 2. Which is approximately, what would that be, 0.69 about. plot this on your sign chart. Our zeros are 0 and ln of 4 over 2. Test points, -1, 0.5, and 1. Plug it, and don't forget you have to plug it into the inequality that had the 0 in it. I forgot to mention that in part B. So if you plug -1 in, 0.5 in, and 1 in, what do we get? We get positive, negative, positive. Now our inequality is worried about when it's less than 0. Oh, I forgot to put my closed or open circles. Because there's no equal sign, it'll be an open circle on both the zeros. So then our answer is 0, ln of 4 over 2. Part D, again, do not multiply by the ln of x plus 1. Instead, we're going to subtract 1 from both sides. We get 1 over ln of x plus 1 minus 1 less than or equal to 0. Well, now we're worried about where it's undefined here. Well, the first thing we have is a logarithm. So because of the logarithm, I know right away my domain, the biggest my domain can be is 0 to infinity, not including the 0. But then we also have that the ln of x, yeah, I'll do it right there, ln of x plus 1 can't equal 0 as well. So we subtract 1 from both sides, and then e it up from both sides. So it can't equal e to the -1, which is approximately 0.37. Okay. Next, we have to worry about when it's equal to 0. Multiplying everything by, because now it's an equation, I can multiply everything by the ln of x plus 1. So we get 1 minus ln of x minus 1 equals 0. The 1's cancel out. So we get negative ln of x equals 0. Divide by -1. And then e it up on both sides. Well, e to the 0 is 1. So now for our sign chart. Oh, because our domain is 0 to infinity, we have to start at 0, which is an open circle. And then we have e to the -1, which that's part of our domain, so that's an open circle. And then we have 1, which, because we're less than or equal to is our inequality, that will be a closed circle. Now for test points, I don't know, let's do 0.2, 0.5, and 2. Now, when you plug these in, what do we get? We get negative, positive, negative. And since our inequality is when is it less than or equal to 0, we get 0 to e to the -1 power, union, bracket 2 to infinity. Okay. I know this video is going longer than the others, but we only got 2 more to do. Okay, so for e, so let's get everything on one side. So we get log base 2 of x squared minus 2 log base 2 of x minus 3 is less than 0. The domain, because of the logarithm, is 0 to infinity, But there's no fractions or anything else like last time, so this is just our domain. There's no other undefined points. Now we could do u substitution, but that only works well for equations. But that's what we're going to end up doing. We have log base 2 of x squared minus 2 log base 2 of x minus 3 is equal to 0 now. And like I said, you want to do a u substitution, so let u equal log base 2 of x. So we get u squared minus 2u minus 3 equals 0. That's u minus 3, u plus 1 equals 0. That's u equals 3, or u equals negative 1. Plug the u back in, so we get log base 2 of x equals 3, or log base 2 of x equals negative 1. 2 it up on both sides for both equations. We get x equals 2 cubed, which is 8, or x equals 2 to the negative 1, which is 1/2. So now for our sign diagram, we have to start at 0. Then we have 1/2. Because our inequality does not have an equal sign, that'll be an open circle. And then at 8 will be another open circle. So we could do 0.2, could do 1, and we could do 9. Notice that my drawing is not to scale. Now plug those in and see what we get. And we get positive, negative, positive. Our original inequality was less than, so our answer is 1/2, comma 8, parentheses on both sides. And finally, for part F, again, I'm going to subtract the t from both sides so that we get 0. T log of t plus 1 minus t greater than or equal to 0. The domain this time is not 0 to infinity because of the plus 1 in the parentheses of the log. Instead, it's t plus 1 is greater than 0, so t is greater than negative 1. Then we need to solve for when a equals 0. Which we can factor a t out. Then we get log of t plus 1 minus 1 equals 0. So we get t equals 0. Or log of t plus 1 minus 1 equals 0. Add the 1 to both sides. 10 it up on both sides. Subtract 1 from both sides, so we get 9. So our sign diagram starts at negative 1. Then we got 0 and 9. And because of the equal sign, it is solid dots above those two. Then we could do negative 0.5, 1, and 10. And what do we get when we plug those into the original inequality up here? And we get positive, negative, positive. This time we are looking for greater than or equal to 0. So our answer is negative 1 with a parenthesis, 0 with a bracket, union, 9 with a bracket, to infinity. And that's it for this section of notes.